So our next speaker here is Matt Johnson, and Matt is the developer advocate. He leads developer advocacy at Bridgecrew and had previously done so at Cisco as well. Now he's going to be talking to us a little bit about integrating policy as code into our automated DevOps pipeline, our CI/CD pipeline, talking a little bit about some open source tools, I think, that they have released. So Matt, I'm going to hand it over to you.
Thanks very much, Frank. Thanks for the intro, and hi, everyone. And thank you to Powell for the previous session. It ties in actually really nicely with some of the topics. It's funny, I've just heard it was 2 a.m. where he is. I was about to comment on it being 1 a.m. here, but it seems I've been beaten in the time zone stakes. Well, hi, everyone. Thank you very much for having me. And thanks for the rest of the sessions and the conference. I'm here, as kind of Frank's just mentioned, to talk about kind of integrating policy into your code in your CI/CD pipeline. So doing the whole DevSecOps thing, I guess you could say. My name is Matt Johnson. I'm a developer advocate at Bridgecrew. And you can find me on Twitter at Metahertz, or join our kind of codified security Slack channel at slack.bridgecrew.io, where we have channels for all the open source tools we're going to talk about today, as well as just general conversation on all things security as code and kind of embedding security in infrastructure as code. So with that said, let's get straight to it. We're going to, that was the intro, by the way. We're going to cover a little bit of context, first of all, kind of why security is code. I'm sure for a lot of you, this won't be new news, but just for kind of completeness, we'll cover like the problems we're trying to solve. We'll then look at some of the options for solving infrastructure as code security, especially during kind of the pipeline. And then we'll introduce some of our open tools and why we release them and how we think they, help the security posture within an infrastructure as code setup. So infrastructure as code security as a 1,000-mile-an-hour view. Obviously, anyone using the cloud right now, you are not going to be using the cloud via the Amazon UI or the Google or Azure, and I will probably use one of them throughout the rest of this talk. So please don't be offended. Pick your favorite cloud provider. Realistically, the cloud is being codified. You're not going to get anywhere using the cloud if you're doing it manually, piece by piece, VM by VM. So infrastructure as code, be it Terraform, be it CloudFormation, be it serverless framework, like infrastructure as code is becoming best practice. And while that is definitely the right way to do it, it allows us to source control and version and audit and gain repeatability of our cloud deployments. It does add an extra layer. It adds an extra learning curve. It adds an extra layer of complexity. And obviously there's multiple options to choose from. Some are cloud dependent, some aren't. And so it does add kind of extra burden on the teams having to manage these infrastructures. And also during that kind of shift to kind of cloud becoming codified by default, we're also seeing the shift from responsibilities of who owns that cloud infrastructure. With DevOps and with the ability for development teams to kind of, cloud infrastructure around their own blockers, if they need new database services, new caches, new pipelines, development teams are now able through DevOps to kind of provision and kind of, create the infrastructure they need to move forward with their development goals, be it new features, be it bugs, be it performance, be it scalability. But with that, especially in most public clouds that expect this kind of shared responsibility model, it means that the engineers deploying that infrastructure as code are now also responsible for securing and assuring the security of that infrastructure that they're deploying. Whereas historically, either in the kind of much more pre-specified VM days of cloud, or even before that when we were talking about on-premise, You'd have a security team that was kind of centralized, and their goals were much more different than an engineering team of today. It was kind of threat orientated, caring about the security, the auditing, and the security response of that infrastructure. That infrastructure would probably be vetted by the security team before becoming kind of a gold standard or a gold image, which was passed on to engineering. With that kind of infrastructure creation ability now being passed to engineering in DevOps, we see that the engineering team are having to take on some of that security responsibility for that infrastructure as well. And that becomes a bit of an issue when, an engineering team, as I said, has a very different set of responsibilities than the kind of security team. I would find it hard as a purely security person in a full-time security role to remember all of the best practices and secure defaults and CIS benchmark suggestions, along with, payment card industry compliance and all the other compliance requirements. I'd find it very hard to remember all of those for every, growing day by day cloud service or API across multiple clouds, or even just one cloud, as well as doing, an engineering, without the engineering day job on top of it. So having engineers expected to do all this is obviously tricky. There is a requirement for this responsibility to be on engineering with the infrastructure, but at the same time, it's a learning curve, and it's something that won't happen without help. And so the other thing we see with our customers and with kind of conversations we have with partners and people in the industry is the cloud's being codified. The developers are kind of responsible for a lot of the security configuration of this infrastructure they're creating. But a lot of these tools weren't designed for engineering. As I said, a lot of this security responsibility has historically been with security teams. Those security teams have been doing this job very, very effectively for years, and have kind of built up their own set of tools to automate, response dashboards, and to automate kind of scanning of test environments before releasing that as kind of a secure infrastructure or a secure default. Most of those tools weren't designed from an engineering standpoint, though, so they don't really speak the kind of day-to-day development language. And the day-to-day development language is kind of IDE, commits to a fork or commits to a branch, tests, pull requests, more tests, automated or kind of gated CI/CD to production. So a lot of these tools are leaving gaps in the fact that they aren't where developers are day to day. So if you're expecting a developer to then go into a set of kind of security dashboards, which kind of breaks away from their normal kind of routine, their normal pipeline, we're just asking for that kind of issue where things that should be kind of directly in the day-to-day mindset kind of get overlooked when things get busy, or when fires happen in production, or when things get crazy. And so what that leads to is configurations in these DevOps style infrastructures, Terraform, CloudFormation. We see configurations ending up in production that should never really have got to production. So an S3 bucket that's meant to be private might not be private, or an IAM configuration is so wide it actually allows someone that's not meant to have any permissions on the platform being able to assume an admin role. And as we've kind of just seen from some of the previous presentations. So and this is not to say that any of the IAC teams, any of the DevOps teams are necessarily doing anything wrong. We all know that when you are moving forward at pace, especially having to do things like infrastructure as code, we've all done it, right? We've all gone and searched for inspiration on how to solve a problem from GitHub, or in the case of Terraform, the Terraform registry, or in the case of Kubernetes, a Helm chart that installs the latest thing we need to get to the point where we can use it, test it, and deploy it. And, the same with infrastructure as code. These templates online are focused on usability, not security. And we've actually done some research and kind of used a lot of our static analysis tools to kind of scan a lot of the public repositories and collections of infrastructure as code templates, and kind of looked at them from a security standpoint rather than a getting started standpoint. And the key takeaway is they're all kind of there for usability. It's how quickly can you kind of take this piece of Terraform or a piece of serverless and kind of get something up and running, help chart for that matter. Again, like the cloud providers, pick your own. I'm not going to keep naming all of them. But how quickly can you get something up and running rather than, oh, but when you're doing this, you're also going to need this dependency, and to make sure you've set up this key management store, and to make sure you've got Vault, and yada, 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 yada. That's not really what these snippets online are designed at. They're designed at answering a specific question of how do I do X? And so it's that security usability thing that we come to time and time again in security, but we're seeing it again in infrastructure as code. So, take whichever meme you want from this, either the wonderful fake O'Reilly copying and pasting from Stack Overflow book, or the, or the much, much simpler, give me a second. I have no idea what just happened to that slide. There we go. Or the much, much simpler Control-C, Control-V keyboard. But whichever meme you want to take, these code snippets are designed for usability, not designed, and they all say it on them, as pretty much every piece of code does. This is a demo. This is a simplistic getting started guide. This is not designed to end up in production. But we all know that sometimes these things do. And a secondary dashboard where you go to check security is not necessarily going to work in this mindset. And so based on that scanning of those kind of infrastructure as code repos, I covered a couple just kind of offhand, but we see things like, logging isn't disabled by default, or databases are left unencrypted at rest, or by default HTTP is enabled rather than HTTPS endpoint, because it means you don't have to configure certificates off the bat. Kind of everything that Powell was saying about, things that might be there, that maybe you don't want to be there. We see a lot of that in those kind of default usable first rather than security first kind of manifests. And so all of this kind of highlights the problem that, DevSecOps is kind of the new bottleneck. Like, if you try and use the traditional tools in kind of a very automated CI/CD process, they might get overlooked. If you try and do manual resource scanning and remediation, you're not going to move quick enough for the actual speed and cadence at which the dev teams are deploying and implementing bug fixes and all the other good stuff that's happening there. So Bridgecrew's view on this is that for security to really work in this context for infrastructure as code, it needs to happen where developers are, where code happens, basically. It needs to be within CI/CD. It needs to be at the developer's eye line. And so there's a couple of ways before we kind of look at solving these. There's a couple of different ways of kind of assuring security within a cloud environment. And I kind of call this like solving versus patching. So you can do something at the start, or you can do something when it's already there. And we'll see that both are important and both are effective. But just to cover these very quickly. So Twilio's sockless automated security runbooks are always an example I use. It's a really neat open source project by Twilio. If you've not seen it, just Google Twilio sockless and find it on GitHub. But it's basically using a set of kind of simple Amazon constructs to automate a way based on security events. A lot of the kind of manual remediation that a kind of security team would historically have to do, leaving time for that security team to work on more complex issues, and just kind of automate away the, the general fire hose of everyday kind of security patch and fix things that are always necessary. But what's interesting with this is, where do these security alerts come from? And in our case, we have a couple of options. So historically, we've thrown everything from our infrastructure from our applications, from our logs that our applications are piling out, from things like network devices or virtual network devices, from firewalls. We've piled everything into some kind of large elk stack or event stream, and then kind of done activity-based monitoring of things that we have already predetermined look questionable. So if something suddenly starts spitting out X number of times more logs for a given thing than it did, we might want to trigger an alert. If something says, hey, we've updated a config, we might want to trigger an alert. If we'll probably have a set list of things that we're manually searching for that we know are bad, and trigger an alert. And so that's kind of historical, event activity based. We've done that right from kind of before we had APIs under our infrastructure. So right back when we had kind of bare metal infrastructure in data centers, we're very familiar with this way of triggering a security response to a known or, trend of logs. And then with kind of public cloud, raised this ability to basically have these pretty full-featured APIs under pretty much every part of infrastructure that historically we might not have had APIs under. So we, as has just been kind of discussed in the last talk, which, like I said, ties in perfectly, things like Prowler. We really like Prowler within Bridgecrew as a runtime detection tool. These kind of tools can go into those APIs and query runtime current snapshot of kind of security issues that they pick up based on real cloud infrastructure that's configured and live right now. So, this potentially gets us a lot of answers to our current state, potentially quicker than kind of trawling through logs and things like that, based on the fact we now have these API capabilities under all our infrastructure, so we can immediately query kind of security settings and pardon me, access control lists and security groups, and whether a key is available or whether a bucket's public and things like that. The thing with that, the runtime solutions, is it's kind of patching, and especially when it comes to infrastructure as code, because with infrastructure as code, the chances are your entire infrastructure is going to get reverted to whatever your infrastructure as code manifests say on the next deployment. So patching is good. It closes a bucket from being public now. It closes an IAM ACL from having too many permissions now. But if that IAM policy or if that bucket was set in Terraform, for example, the next time you do a Terraform apply, you're effectively going to overwrite with the more vulnerable scenario, which brings us to our open source tool, Checkoff. So Checkoff takes more of a build time, a static analysis approach to the same problem, and works really, really well with the runtime tools that we've just been talking about and in the previous session. So the idea with Checkoff is it can determine things that are going to create vulnerable infrastructure before they actually become components within a cloud provider. So by reading and parsing Terraform manifests, CloudFormation manifests, serverless manifests, and Kubernetes, deployments, Kubernetes pods, and Kubernetes kind of YAML files, we can kind of check those against known weak defaults, known things that will cause vulnerabilities. Again, an easy case I always use is kind of the public S3 bucket, or an IAM configuration with stars to allow anyone to assume it as the principal. Going really deep into things like, encryption at rest for databases, or databases that once you've created them can't actually be have security features enabled. So you really do want to know that before you create that item in Terraform or any other infrastructure as code solution, because as soon as you've created that and started using it, you won't be able to go back and apply kind of the same set of security policies. So Checkoff does static analysis of these manifests, and whether you're integrating it as a commit hook or running it locally on your machine, because it's just a binary that we install written in Python with pip, it's really useful for kind of spitting out a set of concerns for the infrastructure you're about to create. And there's no better way of demonstrating that than TerraGoat. So TerraGoat, and we also have one called CFNGoat for CloudFormation, are two complementary open source tools that we've created that basically are vulnerable by design, Terraform, and CloudFormation. So the idea being you can check out these repos, you can run Checkoff against them without having to create any AWS or Google or cloud configuration, without having to create any actual infrastructure and incur any costs. You can do it all local on your machine and see what Checkoff gives you in terms of visibility against just a local non-deployed Terraform or CloudFormation template. And then once you're comfortable with that, you can very, very simply integrate that into your CI/CD pipeline. And actually, we have GitHub Actions that automate that for you. So you can literally go and find the Bridgecrew GitHub action or the Checkoff GitHub action, both of them, much of a muchness in this case. And that will allow you to effectively automate blocking a pull request, blocking a commit based on a fail check as to whether or not there are concerns for the security posture of new infrastructure, new Terraform, new infrastructure as code you're writing. Now, due to the time of this talk, I don't have time for a demo, but please do go Checkoff.io and you will see recordings and kind of deeper dives into the tool. Like I said, it's a very kind of simple Python-based tool. It has 400 checks built in straight out of the bat. And you can see here, this is the kind of output you will get. It's also available in JSON format for parsing and doing other things with. But by default, the binary will exit with a 1 if there are any failed checks, and you can actually narrow down the checks you want to use or not use for a given run within your CI/CD. And hopefully just implementing this will just be a really quick step to improving the security posture of your infrastructure as code, even before those components become actual vulnerable infrastructure. So yeah, our message is, use both runtime and static. Both have their place in securing your infrastructure as code deployments. But because runtime can only see what's live and in your environment, be it production or testing, adding a static layer before you actually deploy that infrastructure as code change is also really good practice as well. Thanks for your time. Please do follow up. I'm at MetaHertz, or we have the Slack community at slack.bridgecrew.io. Thanks.